welcome to the first online lecture. Today we'll talk about basic chemistry. It's a review of the high school chemistry that you have learned. First of all, what is matter? Matter is anything that takes up space and has mass. The simplest way there's three simple states of matter, namely solid, liquid, and gas. And matters, they can be living or non-living. All matters are made of elements. Elements, they are substances that they cannot further broken down. If there's something that can be broken down, we don't call it element, we call it compound. So we'll go through all of these. When we look at the periodic table, all those are the elements. What are the four most abundant elements in our body? Many people will just tell me that, oh, maybe it is oxygen, carbon, nitrogen, hydrogen, something like this. But there's a better way to memorize it, is that I'll introduce your new favorite Asian friend from now on. So the good way to memorize is Chong. So Chong will be your new favorite Asian friend from now on because his name reminds you the four most abundant element in human body. And some textbook, they said that the six most abundant element, this is from the textbook, the figure and the legend is different. If you read the textbook, you will see that they said that the six most abundant element is Chong, and then with sulfur and phosphate. That's what they said, sulfur and phosphate. But if you look at the graph here, you can see that sulfur and phosphate, they are very low, but calcium is actually higher than sulfur and phosphate. The reason is that calcium, we can find a majority of calcium in our bone. So in case people ask you, in case I ask you in the exam, what are the six abundant elements, you should say Chong and calcium and phosphate. How do you put it? You can call this Captain Chong. So Captain Chong is to help you to memorize the six most abundant elements. But the reason is that calcium and phosphate you can find in the bone. That's why calcium should be the more abundant than sulfur. Sulfur you can find in your hair. It forms disulfide bond. So as you can see that in the text, it said that it is sulfur, the sixth most abundant element. But according to the graph, it is calcium. So in the exam, if I ask you the six most abundant element, I will take the calcium as the correct answer. So I said that matter made up of element, and then element, they are made of these atom, and then atom is made of proton, neutron, electron. What is atom? Atom is the smallest part of the element that will it dictate, control the properties of the element. And in each atom, we have proton, neutron, and electron. Proton, they are positively charged. How you can memorize it is that P goes with P. So proton is positively charged, both P, and they are in the nucleus. Neutron, as the name suggested, it is neutral, so there's no charge, and it is also found in the nucleus. Electron is the negative one, and it moves around the nucleus. That means it is not in the nucleus, but it is around the nucleus. And we give you a first example, is helium. Helium, if you look at the picture here, it has two protons, and then two neutrons, and two electrons. And in here, the charges, we already told you, +1, -1. Atomic mass unit, we consider proton has 1 atomic mass two neutron and one atomic mass, we consider electron has no mass at all. So, and this is important. I test you in the exam for this. The first number on top is the mass number. The second number at the bottom is the atomic number. And this is the symbol for the element. So you have to know that atomic mass is the same as mass number. It's the same term, mass number and atomic mass. Basically, it's the number of proton plus number of neutron. And then atomic number is here, the bottom one is only the number of proton. So I can give you a question in the exam asking you, tell me the number of electron. And I just give you this. And what you need to do, you have to use the atomic mass number or the mass number 12 minus atomic number 6. Then you give me the number of neutron. So I can ask you a number of neutron. Or I can give you the number of proton and number of neutron, and then ask you to give me the atomic mass, or give me the atomic number. Then you do not mix up the terms. So there are several ways I can test you on this, but you have to know how to calculate the different numbers. Periodic table. Periodic table is they arrange elements into different categories. The vertical column is the group, the horizontal is the period. So these are important to know, group and periods. So for this group, group number 8, we call this noble gas or inert gas. Noble gas or inert gas. The reason is that all of these elements, they want to become noble. They want to become rich people. They want to become noble. So all these elements, they will try to imitate the noble gas number of electrons. So in this case, they will become stabilized. So this is the basic rule that we'll talk about in the basic chemistry. Because when they achieve the noble gas number of electron configuration, that we will talk about it later, then they will become stable and we call it inert. And if you look at the group, you see that, okay, group number 1, all group number 1, they have 1 electron on the outermost shell. All group number 2, they have the 2 electrons on the outermost shell. Similarly, let me see, 6. Then you have 4 electrons on the outermost shell in group number 4, and so on and so forth. So group number is useful for you to tell how many number of electrons on the outermost shell. And then period, you see that 1, 2, 3, 4, period tells you how many number of electron shell you have on each atom. We'll talk about the electron shell later. Before we talk about electron shell, let's talk about isotopes. What are isotopes? Isotopes, they are the same atom, same element. That means they have the same number of protons, but they have different number of neutrons. So that's the kind of question that I'll ask you in the exam. Isotope, because isotopes, they have different number of neutrons. Then you can see that the mass number is different here. And they said that radioactive isotopes emit various types of energy as they decay. You may have heard about something called carbon-14 dating. Carbon-14, because it is an isotope of a carbon. So, and carbon-14 is radioactive. So what happened is that in the natural environment, we all have carbon-14 in everywhere, including in our body. But as we decay, the radioactive isotope will also decay due to the half-life of the decay of the carbon, which approximately about maybe more than 2,000 years, then we can guess about the age of the artifact that buried in the ground. And I can ask you the question, okay, the isotope. Oh, one most important thing is that not all isotopes are radioactive. Only some isotopes are radioactive. For example, carbon-13 is not radioactive, but carbon-14 is radioactive. So, okay.